All right, so this is the beginning of Unit 4, Rational Functions. Today we're going to look at kind of an intro to rational functions and also vertical asymptotes. So rational function is a function f of x that is the quotient, the division of two other functions, p of x and q of x, where p of x and q of x are polynomial functions. So what we'll have is some string of possible x's with different powers and stuff, but it will always be integer powers, no negatives, be whole number powers of x, on top and bottom. But we will have x's on top and bottom, which means it's not a polynomial, it is a rational function. So we're going to start with the parent, the most basic rational function, f of x equals 1 over x. So that's what we're looking at here. So the question is, what is the domain? And so any number except what makes the denominator 0, which would be 0. So x cannot equal 0. So we'll say from negative infinity to 0, and then from 0 to positive infinity. Anything except for 0 is good here. But what happens to f of x as x gets close to 0? So if we're coming from the left, if I'm putting in numbers closer and closer to 0 as we come from the left, from the negative side here. But if I put in negative 1 for x, I get negative 1. If I put in negative 0.5 for x, 1 divided by negative 0.5, I get negative 2. Negative 1/10 is going to give me negative 10. Negative 0.01 is going to give me negative 100. Negative 0.001, negative 1000. And so we can see that as we get close to x from the left, our numbers increasingly go down and down and down, so we're heading towards, f of x is going towards negative infinity here. If I come from the right, 1 over 1 is 1, 1 over 0.5 is 2, 1 over 0.1 is 10, 1 over 0.01 is 100, 1 over 0.001 is 1000. So as I come from the right, it's going shooting up, so it's going to positive infinity here. So the line x equals a is a vertical asymptote of f of x if as x approaches a from the left or right, f of x approaches infinity or negative infinity. So if as we're getting close to some number and all of a sudden the graph shoots up to positive infinity or shoots down to negative infinity on both sides, and it might be one side negative, one side positive, or they could both be going positive or both be going negative, then that's going to make a vertical asymptote. So for our purposes here, so for this function f of x equals 1 over x, we would say x equals 0. In other words, the y-axis is a vertical asymptote. All right? Oops, I bet that was off the screen. Sorry about that. Okay. Let's go to the next page here. So find the domain of each rational function and determine what happens to f of x as x gets close to the restrictions here. Okay, so f of x equals 3x plus 2 over x minus 3. Everything's good here except for 3. So I'm going to say from negative infinity to 3, and from 3 to infinity. So we're going to approach 3 from the left, or we're going to approach 3 from the right. So if I'm approaching from the left, I'm going to go 2, and I'm going to go 2.5, and then I'm going to go 2.9, and 2.99, and 2.999. As I go from the right, I'm going to go with 4, and then 3.5, and then 3.1, 3.01, 3.001. All right. So let's see what happens here. If I put in 2 here, if I put in 2, I'm going to have 6 plus 2 is 8 divided by 2. Alright, so as we can see here, I think that from the left this is heading toward negative infinity, and from the right this is heading toward positive infinity. Conclusion then, I would say x equals 3 is a vertical asymptote of f of x. All right. Okay, so notice on this one, my denominator is x squared minus 4. So if I factored x squared minus 4, I get x plus 2 times x minus 2. So both negative 2 and positive 2 are not part of the domain. Negative infinity to negative 2, negative 2 to positive 2, positive 2 to infinity. So negative 2 and positive, everything except for negative 2 and positive 2. So we can see here, we're approaching negative 2 from the left, we're approaching negative 2 from the right. As we approach from the left, we're going to, in fact I'm going to write as x approaches negative 2 from the left, f of x goes to positive infinity. As x approaches negative 2 from the right. So notice my notation here. As I approach from the left, I put a little negative sign where the power is to show that I'm coming from the negative direction, from the left side. And when I approach from the right side, I put a little positive sign there to show I'm approaching from the right side. And then I'm going to say f of x is going to negative infinity. Okay? For positive 2, as I approach, notice I'm approaching from the left, from 1, getting closer and closer from the left side. As x approaches positive 2 from the left, f of x approaches negative infinity. And as x approaches positive 2 from the right, plus sign there, f of x is going to positive infinity. So my conclusion, x equals negative 2 and x equals positive 2 are both, well, abbreviate here, vertical asymptotes of f of x. All right, moving on. So, vertical asymptotes of rational functions. A rational function f of x equals p of x over q of x in lowest terms will have a vertical asymptote at each real zero of q of x. So anything that makes the denominator 0 will cause us to have a vertical asymptote. Notice it does say in lowest terms here. So if you can factor or something, if you're able to factor something out, we're going to do that. So let's look at this. So my domain is everything except for negative 4. Okay, in fact, let's just say x cannot equal negative 4 here. So this, I can't reduce anything here. Therefore, my vertical asymptote is x equals negative 4. All right, number 5, however, I can do some factoring. The top of it is x plus 3 times x minus 3. The bottom is going to be x plus 2 times x plus 1, right? All right, so notice nothing's canceling out here, so we're okay. Our domain's going to be x cannot equal negative 2 or negative 1, and so I'm going to have a vertical asymptote at x equals negative 2 and another vertical asymptote at x equals negative 1. So we have two vertical asymptotes there. Okay. Look at number 6 here. Nothing I can put in, no real number I put in for x here is going to cause this to be 0. Only thing that would do it is an imaginary number, and we're not messing with imaginary numbers. So we're okay with this. We're going to say all real numbers from negative infinity to positive infinity, and we're going to say no vertical asymptote. All right. Let's factor this one. So this one's a little tougher to factor. Let's use I'm going to use the box here. We'll say 6x squared, negative 5 is negative 30x squared. I want two numbers multiply to give me negative 30, add to give me negative 7. Does that work? How about 10 and 3? So negative 10x and positive 3x should work. Negative 10 times positive 3 is negative 30. If I add those together, I get negative 7. So factoring going down, I have 3x. Factoring going down here, I've got a negative 5. Factoring going across, I've got 2x. Factoring going across, I have a positive 1. Notice if I multiply back out, 2x times 3x is 6x squared. 2x times negative 5 works. 1 times 3x works. 1 times negative 5 works. So this denominator factors to 3x minus 5 times 2x plus 1. So my zeros, this is going to give me, this first one has 5/3. X cannot equal 5/3. And this next one's going to give me a negative 1/2. X cannot equal a negative 1/2. Alright, so I have a vertical asymptote at x equals negative 1/2, and I have another vertical asymptote at x equals 5/3. It does not, nothing cancels out with the numerator, so both of those are good. Alright, finally, last thing. Proper rational form. If the degree, in proper rational form, the degree of the numerator is always less than the degree of the denominator. So we're going to use long division to rewrite any rational function in proper form if necessary. And all 4 of these will be necessary. Okay? So let's look at number 8. Y'all see that? Yeah. All right. So we'll do x plus 3. I'm going to divide this into 2x squared plus 0x plus 0. So I'm multiplying times 2x. 2x times x is 2x squared plus 6x. Remember to change your signs. This is negative 6x plus 0. So minus 6. 6 times x. Negative 6 times x is negative 6x. Negative 6 times 3 is negative 18. I'm going to change my signs. I have a remainder of 18. So, proper form then, I'm going to say f of x equals 2x minus 6 plus my remainder of 18 over x plus 3. Alright, so that's going to be my proper form of my rational function there. 2x minus 6 plus 18, my remainder, which is over my divisor x plus 3. Okay, let's do one more here together. X minus 6 over 3x plus 5. This one's going to go 3 times. 3x minus 18. Change my signs. I have 23. So f of x equals my quotient 3 plus, put my remainder of 23 over x minus 6. That is my proper form here. I'm going to pause the video and let y'all see if you can work out 10 and 11. After you've worked it out, continue and you can check your answers. Okay? Alright, so this one's already proper form. That was easy enough. The numerator on the degree on top is 3, the degree on the bottom is 4. Since the degree on numerator is less, we don't have to do anything there. Alright, let's try this last one. X squared minus x plus 1 over x to the 4th plus 0x cubed plus 2x squared plus 0x plus 1. So x squared times x squared here. X to the 4th minus x cubed plus x squared. Let's change all our signs. Negative, positive, negative. So I've got x cubed. I have 2x squared minus x squared is going to be plus x squared. I'm going to bring down my next term. So plus x. This is x cubed minus x squared plus x. Change my signs. Negative, positive, negative. I've got 2x squared minus x plus 1. So plus 2, 2x squared minus 2x plus 2. Change my signs. And I've got x minus 1. So my f of x, see if this is what you got. I've got f of x equals x squared plus x plus 2 plus x minus 1 over x squared minus x plus 1. Okay? And that is it Hope y'all are doing well, and I will talk to you later. Bye-bye.